To verify a possible air induction restriction and eliminate the air filter as a cause, connect a manometer at either the air box inlet or the compressor inlet for turbocharged engines. Run the engine at a typical road speed RPM, say 1800 to 2000 RPM, and measure the pressure. If the pressure exceeds 12.5 inches of water at high idle no load, or exceeds 25 inches at high idle rated speed, the air filter should be replaced and the system retested. Compare the results with the engine manufacturer's specifications. If the induction piping and filter is okay, an air starvation problem in the cylinder may be caused by low turbocharger or supercharger output. The boost pressure can be read on the instrument panel gauge and should agree with specifications by the engine manufacturer. Boost pressure must be measured under load. A common problem with low boost pressure is damage or improper maintenance of the intercooler or aftercooler. Charge air coolers do the same job, lower the temperature of hot pressurized air to increase molecule density. If the cooler leaks, has restrictions, or an airlock, a condition where moisture in the cooler turns to steam and inhibits air flow, the cooler cannot transfer heat and the boost pressure will fall. The symptoms, particularly when the engine is under load, are similar to an air restriction. Now let's look at some of the other induction malfunctions such as airbox leaks and compression loss that can do the same thing. A leak can starve an engine for air as much as a restriction. Air can leak through very small gaps in gaskets as well as valves, pistons, and rings. An airbox leak is usually pretty easy to detect because it makes so much noise. Even small airbox leaks can be detected holding a piece of tubing close to your ear and running the other end around all the seals in the airbox. Once air gets inside the cylinder, it is supposed to stay there until the end of the power stroke. But air can and does get past the valves, pistons, and rings. Leaking valves may be caused by physical damage to the valve face, improper seating of the valve, or incorrect valve timing that allows a valve to open early or close late. Measuring airbox pressure can determine if intake valves are leaking, and measuring exhaust pressure will point out leaking exhaust valves. Some air will normally bypass the piston rings and cause a slight positive pressure in the crankcase. Excessive blow-by, however, will not only reduce the amount of air in the cylinder, it will also lower compression in the cylinder, robbing the engine of power. Measuring crankcase pressure will tell you if the piston and the rings are the air starvation cause. Air going past a cracked piston or piston rings will increase crankcase pressure and might also cause engine oil to be forced out of the dipstick or past oil seals. Defective piston rings of belt-driven or gear-driven air compressors can cause excessive crankcase pressure blow-by, as the oil return is shared with the engine sump. If an engine is boosted either by a supercharger or a turbocharger, loss of boost pressure can also cause higher cylinder temperatures because the exhaust isn't scavenged efficiently. Higher than normal exhaust back pressure will create some of the same conditions as air starvation. High back pressure will also cause low turbo boost. Power will be lowered, exhaust will darken, and cylinder temperatures will increase.